Hi, so this is the Longhorn Community Monthly Meeting, and I'm Sheng Yang, the maintainer of Longhorn. So today is March 13th, 2020, and we're starting at 9 o'clock, and welcome, Jason.
Morning, Chad.
Hey. So today we're going to talk about the Longhorn 0.8 release and some about 0.8.1 planning and what we plan for the GA release. Okay, I'm going to share my screen. All right. So in fact, we just released the Longhorn 0.8 release this week. And as we explained before, that's one of the highlight we included in this release is the volume expansion. But unfortunately, in the last minute, basically just last week, we found that we have a bug in the online expansion, and we decided to delay that part of the feature. So currently, the Longhorn supports offline expansion and also through the CSI as well. And the possibility of re-enable the online expansion, we'll take a look at that after like 0.8 release. So this is in fact one of the oldest issues the user reported in Longhorn, and as a feature request, and finally we are able to fulfill it after 2.5 years. Okay, and also when we get this down, is everything is already say we support you can resizing through the UI, and also you can support we support UI resizing through the CSI plugin as well. And one caveat here is if you are using storage cloud, if you're using Kubernetes before 1.16 release, so the volume expansion will not be available for the storage class. So you are going to have to expand the volume manually, and then the spec of the PVC probably going to be slightly mismatched with your volume in fact, but the thing is that will not going to have a functional effect. For the details on this demo for the volume expansion feature, you can take a look at our monthly community meeting, which we did a demo on, I think back in last December. The second feature is automatic recoveries and salvage from the faulted volume. And in fact, this is the one of the issues that many users has bring up, but we're kind of really debating on if we want to do it automatic or not. Because the thing is, yeah, so as you know, Longhorn is running as microservices, and the engine is always trying to talk with the replicas. If the engine cannot reach a replica, it's mostly due to the network issue, then the volume will become faulted, and we want to in this way and let user know that something is wrong with this volume. And we also expect that as a storage solution, we're going to have network stability requests, so requirements. So you're not really going to just have a lot of frequent network disconnections, and those are basically need to be guaranteed in order for the Longhorn to function well. But the thing is, they are really the Kubernetes cluster is now distributed in anywhere in the world, and there are many scenarios that the network connectivity and the latency and the bandwidth cannot be guaranteed, and there can be temporary network interruption from time to time. So what we've gathered the feedback is users really want to have automatic mechanism to gathering from to recover from that. And in fact, in the last 0.7 release, we have implemented automatic remount and reattach feature if we say the node was rebooted or the Docker on the node was delayed, was killed. So in Kubernetes side, Kubernetes will restart the pod, but previously we don't really have a way to just reattach the volume and remount the volume in this case. But in 0.7, we found a way to recover the volume and make it usable on the host for the pod. So in fact, in the 0.8 release, that's we think it's possible now for us to automatically recover the faulted volume, because if the volume going faulted, it is not really anything. That's not going to cause data corruption, and that's in fact one common misunderstanding. The faulted volume not means that it's state corrupted, but it just means that the engine cannot reach to the replicas. So at least for one moment. So that is what we decided, that in combination of this automatic salvage for the faulted volume and the auto remount feature we have implemented in 0.7 release, we do have a way to automatically recover from the network interruption and even if the engine disconnected from the replicas. So that's why we add this feature in this release, and hopefully can solve a lot of users' problem because of due to the unstable network. And in fact, sometimes I saw people on all kinds of media or like some forum stuff. Sometimes I saw people mention that Longhorn is not really stable, but in fact, it's most likely, most cases we saw is really just due to this network interruption. So hopefully with this feature, we can get better on that. And the third highlight we have here on the performance improvement on attaching and detach. In fact, this is a very interesting issue. So this issue doesn't really exist before the 0.6 release, before we switch to the instance management model from the one engine and one replica per pod. So after that, some user give us feedback. You can click this and take a look. So it takes feedback that attaching and deleting take like 1 hour, which is totally abnormal, and it will happen before upgrade to 0.62, and then to 0.7 still doesn't resolve it. So I take a deep look into what is happening there, and it turns out it's because that we have introduced the instance manager, and so the instance manager going to have the updated status for all of the replicas and the engines. But if you are going to have, let me see. If you're going to have like 30 or 40 or more volumes attached to the one node, in this case, I think that the users have just, yeah. I think the user have, in fact, another case, user report that performance downgrade after 60 volumes. In this case, the user has one very big machine which contains a lot of volumes, and so I think it's my memory code. Let me know. It's about 40 volume. Oh yeah, currently have around 40 volumes. So that is, in fact, we found out that is really the reason why it doesn't work that well. So the machine itself is very powerful. It's like 16-way CPU, 64 gigabytes memory. So that is very powerful. So it should be enough to run like 14 or even more volumes. And as you can see that the CPU utilization is not even high. It's about like 30%. So in that case, we are looking into that and found the root cause is basically how we handle the objects, which is going to be queued and going to be picked up by the controller. So there's one controller, there's one parameter in the controller, and that factor is called work queue. And for every object, we need to put that in the work queue first before it can be picked up and processed by the controller. So in the end, we found that there's the default rate limiter in the work queue is like allow 10 operations per second and up to 100 operations as a boost. So that's in fact compared to if we are having like 40, assuming that we are going to have 40 volumes on one node, that means that there's 40 engines and 120 replicas with default 3 replica per engine setup. And that is basically 160 objects. And 160 objects, if you need to go through that rate queue, that's a work queue in like normal rate, we are going to take about 16 seconds. But in fact, another thing is we are basically, because the instance manager, there can be some status changes, and once one status changes, we're going to refresh the whole thing. So that is one part we need to improve on, but now is basically we can generate about 200 requests per second or 100 something requests per second, but only process like 10 requests from the controller part. So that is the reason for this bug. That is one of the reasons for this bug. Another reason is we do have some unnecessary writes to the SCD. So after fixing that, like just increase the bandwidth for the rate limiter. So we are showing that very dramatic improvement on the overall performance, especially if you are going to have very large of numbers of volumes attached to one node. In the end, when I do a test with 80 volumes on one single node, and we see that the scale right now is pretty linear, and we take about 20 seconds per pod on average. That is including creating the pod, putting the image, and created the block volume and formatted the volume, persistent volume, and attach it and put it to the pod. So that's only take about 20 seconds compared to user reported like 1 hour or more on each operation. And detach take like 4 seconds, and attach itself take like 11 seconds. So I was pretty satisfied with this result, but still we do have more thing to worry about, like this issue I found out because the previous set way of doing the how we process the instance in one batch is going to be a little bit overloaded. So we are going to address that in the future as well. So, but in the end, I think you are going to see less like in the pod description, you're going to see less like mount timeout or attach timeout, those kind of things from happening. And if you're using a very large node to launch instance, to use with Longhorn, you are going to see dramatic improvement if you are using like more than 20 or more than 30 volumes per node. All right. So on the fourth item, support Kubernetes zone and region tags for the replica placement. This I have explained this feature in details in the last, I think it's February's community meeting. So you can check that for more details on this. The progress report for review. So now we finally all our long operation like backup, restore, and snapshot delete and rebuild all has the progress report. But unfortunately, yeah, we indeed find immediately the user reported bug after the progress, after the 0.8 release with this feature. So I was still working on fixing that, and they'll be including the 0.81 release. So on the sixth item, the upgrade, finally, we're able to find a way to re-enable the live upgrade, and hopefully we are able to use that in 0.81 release. So this is in fact the biggest feature in this release in the term of coding and the design and the efforts went in, but it's not really user visible right now. So we're hopefully that this design can hold and we can use that in the future. The basic idea is that when we say live upgrade, in fact, we are going to upgrade the engine itself, but since we introduced the instance manager, the instance manager become this, because instance manager itself is a pod, and it's not really possible to upgrade instance manager itself on the fly. So that is why that we are thinking that because we can reduce the code base in the instance manager and make sure that its responsibility is as limited as possible, then we can increase the stability of the instance manager. So we are basically, what we do is we just split out every engine related function out of instance manager and make instance manager a general process manager and somehow able to achieve the live upgrade using the instance manager without really have the dependency in the Longhorn engine. So in that way that we can upgrade the instance manager separately, and we are also have a separate image for the instance manager now. If you notice that in the Longhorn starting command line, Longhorn manager starting command line, and that image can in fact accommodate to a certain degrees of the Longhorn, the different version of Longhorn engines as long as it's compatible. So that is In that way, we can keep the instance manager as long as it's stable, and we can upgrade the Longhorn engine to provide users more bug fixes and features in the future. So that's in fact, this design was I think back and forth for 2-3 times, and finally we decide to do this way, and hopefully this, as I said, this design can hold for the next few months until we hit V1, the 1.0 GA release. So the last one we do have, say, the Python 2. Everyone know the news. Python 2 is not really officially dead, but it's dead in like new projects. So we completely switched to the Python 3, and that takes some efforts. And gladly now we're no longer need to deal with the Python 2, and also, and as a side effect, seems like the PyTest is getting better and showing like a percentage, which is really encouraging during the PyTest running process. So I would say so far Python 3 is pretty awesome. All right, so if we are upgrading from 0.7 to 0.8 release, we are going to, you need to follow the offline upgrade process, and we hopefully in the next version we can enable the online upgrade, and everybody going to have a easy way without scaling down the workload process to upgrade. So that's all for the 0.8 release. All right, so next 2 releases, we are going to have another 2 releases before the GA as planned. The next one will be 0.81 release. And there are a few highlights here. And in fact, the 0.81 and 1.0 release, we are going to be mostly stable focused release. So we're going to fix the known bugs and try to encourage our users to test this as much as possible. And also we are going to spend much more effort on testing and stabilizing before the GA. So one feature, in fact, probably the only feature in the 0.81 release is we are going to introduce the automatic node and disk setup. And this is the one way that we can help user, can basically automatically, when user trying to scale a Kubernetes cluster to contain more nodes, and if user set up some annotations and or labels on the node after it was introduced, we are able to just pick up the disk and create the default disk according to that specific configuration rather than just using the default disk option. So that is the one improvement from our previous create default disk settings feature. So, and also along with that, we're going to have ability to set the tags and where labels and notations, but also that's only going to be applied to the newly added disk and newly added node. Another 2 part is more like the maintenance, of documentation work. So Longhorn LGAP installation, in fact, Longhorn currently can install any LGAP environment, but there are a few things missing. One is like if your LGAP, if your private repository has a password or credential stuff, we don't really support that, and that's going to be fixed. And then, the second point is we don't really have a well-documented LGAP installation guide. And many people will be able to figure it out, but of course we want to make it easier for the user to get this installed properly next time if they want to deploy in the LGAP environment. And the last one is we're looking at say helping user to restore volume from a single replica, and due to the mechanism, in fact, a single replica restoration is one of the like fault tolerance or you say high availability feature of the Longhorn. So every single replica contains full data of the volumes, so you should able to restore that. And as long as that the replica itself is still intact, even you have your whole class down. So we want to have a better way to help user to work on that. And this is more like usability and not really going to be like a new feature stuff. So in the 1.0 release, we have a few other items, and we can look into that more once we approach that. And currently, we're targeting the 1.0 release at around end of May, and the hard line is we're going to get 1.0 out in the before the end of Q2. So that's about it. Okay. So if there are no question, I'm going to, this is where we call the meeting, and thank you for coming, and see you next time.
Well, one question, Shen.
Yeah.
Do we have any unofficial documents on air gap? Because I did the work I'm already doing on documentation as I get that finished up.
On what?
Do we have any unofficial or comment threads on getting air gap working? Because you mentioned some of the community users having figured that out.
Yeah, so in fact, the LGAP, this thread, we already have something here. So we're working on that already. Yes.
Okay. Sounds good. All right, no other questions for me.
All right. So, okay, so that's called the meeting, and thank you everybody for coming, and see you next month.
See you then.